Welcome to this explainer. Today, we're jumping right into what could literally be the greatest discovery in human history. Is it possible that the biggest cosmic mystery we've ever faced is hiding right now on a frigid, ice-covered moon orbiting Jupiter? We're peeling back the layers of Europa. So, let's get into it. When astrobiologists look out into the cosmos, they're chasing the ultimate prize, right? Extraterrestrial life. But our absolute prime suspect isn't some warm, Earth-like exoplanet thousands of light years away. It's actually a remarkably smooth, frozen world right here in our own planetary backyard, Jupiter's sixth closest moon, Europa. Let's look at the clues we've been gathering to see why everyone is so obsessed with this icy sphere.
Believe it or not, this investigation kicked off over 400 years ago. Back in 1610, Galileo Galilei pointed his homemade telescope at Jupiter and spotted 4 tiny dots, proving once and for all that Earth wasn't the center of every orbit. But the plot truly thickened when our modern space probe showed up. In the 1970s, Voyager gave us our first close look, revealing the shocking, completely smooth, crater-free surface. Then, between 1995 and 2003, NASA's Galileo spacecraft actually orbited the Jupiter system. Its magnetometer picked up massive disruptions in Jupiter's magnetic field, which gave us the first hard physical evidence of a conductive fluid layer right underneath Europa's crust.
The first massive clue to Europa's potential is just the sheer, mind-boggling scale of what we're dealing with. Check out the volume of water here. Europa is actually a bit smaller than our own moon, but because its hidden underground ocean is estimated to be anywhere from 40 to 100 miles deep, this tiny little moon is hoarding more than twice the liquid water of Earth's entire global ocean combined. It's just wild to think about. This visual forensic model perfectly illustrates the scene we're investigating. Europa is highly differentiated, kind of like a giant jawbreaker. At its very center, there's likely an iron-nickel core, completely wrapped in a silicate rock mantle. Sitting right on top of that warm rock is this incredibly deep, global, briny ocean. And finally, the whole shebang is capped by a rigid outer shell of solid ice, which scientists estimate is roughly 10 to 15 miles thick.
But looking at that structure brings up an obvious, glaring mystery. Europa is incredibly far from the sun. The surface temperatures there plummet to an agonizing minus 370 degrees Fahrenheit at the poles. Under those freezing conditions, how does this massive volume of water not just freeze completely solid, all the way down to the bedrock?
The answer is something called tidal heating. See, Europa's orbit around Jupiter isn't a perfect circle, it's elliptical. That means its distance from Jupiter is constantly changing, and so is the immense gravitational pull it experiences. Because of this, Europa gets continuously stretched and relaxed by Jupiter's gravity. Think of it like taking a metal paperclip and repeatedly bending it back and forth. You know how it gets hot? Well, this intense internal friction literally kneads the moon's rocky interior and ice shell, generating enough heat to keep that massive subsurface ocean in a liquid state.
And that immense energy doesn't just warm the ocean below, it completely scars the surface above. Looking at the forensics of Europa's leading and trailing hemispheres, we see this fascinating split personality. The leading hemisphere features much purer water ice, but the trailing side? It's heavily bombarded by radiation and plasma from Jupiter, and it's coated in these mysterious reddish-brown non-ice materials. Scientists are pretty sure these are hydrated salts and sulfur compounds, which might actually be getting dredged up from the ocean underneath.
Section 1. Deciphering the chaos terrain, the scars of a restless moon.
Those distinct reddish materials we just mentioned aren't scattered randomly. They're heavily concentrated around Europa's geological scars, which brings us to our next major clue, chaos terrain. It basically looks like an Arctic crime scene. You've got these floating ice rafts, massive, geometric fragments of the crust that have totally broken off, drifted, rotated around, and then refrozen right back into place in these crazy jumbled configurations. It's spectacular proof that this is a highly dynamic world. It tells us that plumes of warm ice, or maybe even hidden lakes of liquid water, are actively churning just below the surface, causing that brittle outer crust to collapse and splinter.
Right alongside that chaos terrain, you'll find lineae. These are vast networks of crisscrossing cracks and double ridges that streak across the entire globe, some of them stretching for literally thousands of miles. As Europa's icy crust violently stretches to handle all that tidal stress from Jupiter, huge fissures just open up. Warm ductile ice or briny water from below pushes up into these cracks, freezes, and creates these very distinct reddish-brown lined ridges.
Section 2. The Recipe for Life, Establishing the Motive.
So, we've established we're looking at a deeply dynamic, churning environment where the surface and the ocean are likely interacting. But does Europa possess the actual motive for our investigation? Does it have what it takes to support life? Well, astrobiologists have a basic life checklist, and Europa cleanly checks all 3 boxes. First, liquid water. It has a vast, stable ocean that might have been there for 4 billion years. Second, chemistry. Essential building blocks like carbon, nitrogen, oxygen, and sulfur are likely present from the moon's formation and from cometary impacts. And third, an energy source. The tidal heating provides warmth, and water-rock interactions down at the seafloor could create chemical energy, very similar to the deep-sea hydrothermal vents we have right here on Earth.
But the energy story gets even wilder up on the surface. Data from the Juno spacecraft threw us a fascinating twist. Jupiter's intense radiation belts are constantly blasting Europa's icy shell. And that radiation actually splits the water molecules right on the surface, generating a tenuous but oxygen-rich atmosphere. Here's the exciting part. If the ice is churning like we think it is, some of that surface oxygen could theoretically seep all the way down into the ocean below, giving a vital fuel source to any potential biological activity. Now, for a while, we were really hoping Europa was actively venting its ocean water directly out into space. Initial Hubble telescope data seemed to show massive water vapor plumes. That would have been a total game changer. We could have just flown a spacecraft right through the spray and sampled the ocean directly. But recent reanalysis by scientists at the Southwest Research Institute suggests those signals might actually just be statistical noise based on camera placement. That doesn't completely rule out plumes, but the case just isn't rock solid anymore. And it means if we want to solve this case, we're going to have to go deeper.
Section 3. The next great mission. Returning to the crime scene.
To definitively crack this cosmic case, staring through telescopes from afar just isn't going to cut it anymore. Enter NASA's Europa Clipper mission. Launched in October 2024, this incredibly advanced spacecraft is set to arrive at the Jupiter system in 2030. It's not a lander, but it's going to conduct 49 terrifyingly close flybys. It's packed with instruments designed to map out the chemical composition of those reddish materials on the surface, use ice-penetrating radar to accurately measure exactly how thick that shell is, and confirm the precise depth and salinity of the hidden ocean.
But scientists at JPL, they're already planning the ultimate heist, breaching the ice shell itself. Looking further down the road, engineers are actively testing cryobots. These are torpedo-shaped probes powered by chunks of plutonium. The heat from radioactive decay would literally melt a path straight down through 15 miles of solid ice. And once it finally hits the liquid ocean, the cryobot would deploy swim, sensing with independent micro-swimmers. We're talking about palm-sized, 3D-printed swimming drones that would fan out into those dark alien waters, using miniature sensors to hunt directly for chemical biosignatures. Absolutely sci-fi stuff, but it's real.
Which brings us to the ultimate question. What if these future missions do breach the ice? What if they discover that the origin of life isn't just some miraculous one-off event that absolutely requires a sunny, warm surface? If life is robust enough to spark in the pitch-black, frigid, pressurized depths of Europa, what does that mean for us? It would profoundly shift our entire perspective of the cosmos. It would suggest that our universe isn't a barren desert, but might actually be teeming with inhabited alien oceans hiding right beneath the ice all over the place. I hope this explainer sheds some light on the incredible, ongoing mystery of Europa. Thank you so much for joining me on this journey into the deep.